This is the video for Mod 5 Lesson 4, Applications of Systems, or Solving System of Equation Word Problems. The goal of this lesson is going to be using elimination or substitution to solve system of equation word problems. And these are similar to questions you could potentially see on an SAT. So the first question we have here, and we're going to see a couple of different types of problems. So some have to do with where you're going to have y equals type problems or x equals, and you're comparing two different places. So that's kind of what we're seeing in example 1. So we're looking at comparing in this problem Home Depot with Menards. So I always like to kind of think of these word problems as these are the ones where you're kind of doing some comparison, where you're comparing gym memberships or stores or some other businesses. So a lot of times these kind of follow the same type of pattern where you have a variable on a side by itself and you're including like rates and costs and so forth. So what we're looking at here is it says Home Depot charges a flat fee of $25 plus $4 a day to rent a snowblower. It then tells you Menards, which is obviously a different store, charges a $28 flat fee and $2.50 per day, right? So a flat fee means even if you did nothing on that day, you still have to pay it. And then you have like an hourly or daily rate that you're paying that changes throughout the problem. They also give you these different variables. So write on a system of equation where C is the cost. So I'm going to write C is cost per renting, and D is the days. With word problems, it's very rare that the SAT lets X and Y be in the problem, so we're going to use C and D, even though we know that's similar to X and Y, just so you kind of get familiar with seeing that. So what we're going to do is it says that I'm going to start first with Menards, so that's our first equation. And we know it's whatever it's going to cost, so I'm going to let C equals. That's really what we're comparing here is the cost. And it says that it's going to be $4 per day plus $25 for a flat fee. Or actually, that's Home Depot. There we go. There's Menards. So yeah, Menards is going to be $2.50. So your cost is $2.50 a day plus $28. We then also have Home Depot. I'm going to put home. And their cost is $4 a day. You can see there's either $4 a day and $25 flat fee. So the question is, write a system of equations for renting a car for each of the days, and then we're also going to solve it out, right? So some might ask, okay, write in a system. This would be the system. If we wanted to solve it out, a lot of times these ones are a little easier to solve, but we get kind of thrown off because they're both C equals. So like if you did substitution, the C's are both by themselves. That actually makes it kind of a little easier to do. All we really have to do is set the expressions equal to each other, and we can get our final answer. So 4D plus 25 is equal to 250 plus 28. And then we would just go ahead and simplify and solve. So this would be now 150 times D plus 25 equals 28. So 150D equals 3. And then D would be equal to 2. And the question might say, when are these going to be the cost the same? So at 2 days, these would cost exactly the same. And if I substituted 2 back in, that would give me $33, right? So at 2 days, they would cost exactly the same, and it would be at $33. So if they asked when these would be the same, that's what that point of intersection would mean. Number 2 is a different type of word problem. These ones I like to call, like, they're almost like combination problems, right? So you're taking a combination of, in this case, it's vans and buses. Sometimes they're like, oh, you're buying pizza and hot dogs, or something where you're buying a different number of 2 different items, and you're having to write a system. So this question says the junior class at Andrew and Sandberg planned separate field trips to Great America. The junior class at Andrew rented and filled 14 vans and 10 buses with 534 students. Sandberg filled and rented 13 vans and 5 buses with 303 students. Every van has the same number, and so do the buses. So write a system, and this one's actually letting you use X and Y. But you again, it can kind of switch off a little bit. So this one's saying X is the number in the van, and Y is the number that are in the bus. How many students are in vans and buses? And just thinking about it, you know, vans are smaller than buses, so whatever we get for X should be smaller than Y, because a van holds much less people than a bus, right? So this kind of keeping that in mind. So we have one that's comparing a combination of vans and buses for Andrew. So Andrew has 14 vans and 10 buses at 534, and Sandberg has 13 vans and 5 buses at 303. So we're going to go ahead and write that system out. So 14x plus 10y is 534. And then we have 13x plus 5y is 303. This is definitely one where we can use elimination. And you can eliminate the x's, but you might see y is a little easier, right? I can multiply 5 by 2 to get 10. I want them to be opposite signs, so I'm going to do -2. And then we're going to go ahead and solve using elimination. So I'm going to write this off to the side here. So the top equation for us didn't change. The bottom equation, -26x minus 10y equals -606. We're then going to add these straight down. The y's go away. We're going to end up with -12x is equal to -72. And then if we go ahead and solve that out, we're going to get our answer to be 6. And then if I wanted to find what my y was, I could substitute it anywhere I like. Maybe I'll use this one down here. And then we would just substitute in that 6. And so 13 and 6 would be 78, and then we'd go ahead and solve it out. And so we get y to be 45. So what that means is if we let x be the number of kids in a van, so there are 6 students per van, and y means that there are 45 kids per bus. In this example, we're looking at money and coins. So this one says that we're going to be letting x be nickels, y be quarters, and they first tell us how much money that's worth. It's worth $3.10, so we're going to have then 0.05, because a nickel is 5 cents, plus 0.25, because a quarter is 25 cents, is going to be $3.10. We also know the number of nickels, which is x, is going to be 1 less than 4 times the number of quarters. So that's going to be 4y and then subtracting the 1. So when we do this problem, we're maybe going to want to do substitution. Might be a little easier. When we substitute this in, we get 0.05x. In x, we're going to put 4y minus 1. And then plus 0.25y equals 3.10. We're going to distribute. So we'll get 0.02. minus 0.05 plus 0.25y equals 3.10. All right, so now when we solve this, and actually, I'm sorry, this would actually be 0.2. There we go. So 0.2y, sorry, minus 0.05 plus 0.25y, and so forth. So when you get to here, this might be like a little overwhelming to look at. You can solve it as is. What you might notice though is actually if you multiply all this by like 100, this might be slightly easier to solve for. You could do that if you like. If that overwhelms you, just solve it as is. It's not, you're going to get the same answer. So if I put this together, I'm going to get 0.45y minus 0.05 equals 3.10, and then just solve from there. So when we get that, we get our y value to be 7. And then if I substitute it in here, I'm going to get x to be 27. So basically what that means is I have 7 quarters and 27 nickels. If you have questions from the notes, please make sure you're asking questions in class, during T-Bolt time, or in the center. You do need to complete the U-Tries to receive full points for these video notes. So when these are checked in class, you do need to make sure you have your U-Tries completed to receive full points. So again, the remaining problems from this section need to be completed, even if they're not perfect. We need to see that you're trying the steps out before you come to class so you're ready to ask questions. All right, thank you very much and have a great rest of the day.